take the natural log of each side. Remember, natural log is the same as log base E. So taking log base E of E pretty much cancels that out. And we proved that algebraically in our notes. So ln of E to the 3k power equals ln of 60. These cancel here, so 3k equals ln of 60. And we're going to go ahead and solve for k by dividing by 3. Go ahead and use your Desmos here. Function ln of 60. Don't forget to close your parentheses here. Divided by 3. And our answer is 1.365. So that's your answer for K. All right, let's look at B. Go ahead and work on that one. Tell me what you get in the chat. We're on B now. Thank you. I see some responses already. I'm working it out here on the side if you're not quite sure yet, if you need help getting started. Okay, thank you. Looks good. Did you guys close your parentheses? Try that again. All right. If you are not done or you are just completely lost, put a question mark or not done. So good. I'm seeing good answers there. Yeah, either put your, okay, thank you. Question mark is okay. That means I know you're still there. Make sure that when you are calculating that you are closing your parentheses. Okay, so here we are. I've worked it out. We have e to the v plus 7 power minus 10. We want to isolate our e first by adding 10 to both sides. So we have e to the v plus 7 equals 68. We took the natural log of both sides. When we take the natural log of e, it cancels and brings that exponent down. So we have v plus 7 equals the natural log of 68. I'm going to solve for b by subtracting 7. So I have v equals the natural log of 68. Natural log of 68. And notice you're going to get a different answer if you don't close your parentheses. So make sure that you're closing your parentheses. I don't want to find the natural log of 68 minus 7. I want to find the natural log of 68 and then subtract 7. So we should get a negative 2.78 there. All right, let's try the next one. Let's try this letter C. Not sure where I'm going to work it up here. So I have a negative e to the x plus 9 plus 2 equals 35. Yeah, so Jake asks, is this on the test as well? This is a big part of the test, doing this part, or a small part. We're going to do it in just a second. All right, so I'm going to solve for that e by subtracting 2. So I have a negative e to the x plus 9 equals 33. And see, we have a negative here, so I'm going to get rid of that. So we have e to the x plus 9 equals negative 33. Take the natural log of both sides. So we have x plus 9 equals natural log of negative 33, and then subtract 9. So let's see what this is. I should have done it in my journal. It's getting kind of messy.
0.
Huh?
0.
0?
Or undefined.
Yeah, so it can kind of tell you here a natural log of a negative number is undefined. Why is that? Okay, so in our notes, you can copy that down. In our notes, we talked about Newton's law of cooling. Newton's law of cooling is uses our constant number E here, or Euler's number. We did the first example together with the cup of coffee. If you haven't watched the notes yet, I would really suggest going back to watch those notes first before starting the test. But we're going to do the second example together. And this is going to be a lot like your test. Okay, that's why I wanted to do it with you. Okay, I should probably get my notebook out. If you don't have your math journal out, I would suggest getting it out because you're going to want to know this. Or a piece of paper or whatever. All right, so we have a situation here. At 8:30 a.m., a coroner was called to the home of a person who had died during the night. To estimate the time of death, the coroner took the person's body temperature twice. At 9 a.m., the temperature was 85.7 degrees Fahrenheit, and at 9:30 a.m., the temperature was 82.8 degrees Fahrenheit. The room temperature was 70 degrees Fahrenheit. When did the person die? So here's our steps below. It'll help us as we go through and solve the equation or the function. Notice when we took our notes the first time, we have to find that constant rate of cooling first. Sorry, it's blurry. We have to find that constant rate of cooling first, and then use our new function to find how much time will pass. So we're going to do the same thing, and what we learned was that it was going to take 11 minutes for it to cool down to 155 degrees. We're going to do the same thing, except we're going to work a little bit backwards, okay? All right, so let's talk about things that we know, right? I'm going to write down Newton's law of cooling. By the way, this is what coroners use to find out time of death. So we have T of T equals the starting temperature, or the surrounding temperature, the initial temperature minus the surrounding temperature times our constant E to the negative K, which is our cooling constant or our decay constant, times T time, okay, time elapsed. So what do we know from our situation here? We know that the coroner went to the house at 8:30, right? So he took two temperatures. He took a temperature at 9 o'clock, and it was 85.7 degrees. He took another temperature at 9:30, and it was 82.8 degrees. The other thing that we need to know is that the surrounding temperature, or the room temperature, was 70 degrees. Okay, so let's start labeling what we know, right? Pull out if you have questions as we go along, please just put them in the chat and I'll answer as we go. So our T of S is that 70 degrees, right? So T of S is 70 degrees. It's our surrounding temperature. And then our initial temperature, we're going to start here, 85.7. And then we want to think about our time elapsed, right? So we're going to think about this in hours. You could do minutes if you wanted to. It's really up to you. I would suggest doing, well, it really doesn't matter. I would suggest doing hours. So our time elapsed here, this initial time elapsed is 0.5, right? It's half an hour. You would get the same time if you used minutes. And let's see, what do we not know? We don't know our cooling decay constant here, but we do know that at that half an hour, T of 0.5, it was 82.8, right? So think about this, you can't solve an equation with more than one variable. You need to narrow it down to just finding one variable. That's exactly what we've done. We've identified 4 variables, and now we're just looking for that decay constant. So let's plug everything in. We have 82.8 equals 70 plus the initial temperature, which is 85.7, minus 70 times E to the negative K times 0.5. All right, now we're just going to narrow it down to maybe look like the equations that we were solving on the first page. So let's do 82.8 minus 70. We get 12.8 here equals 85.7 minus 70, which is 15.7 E to the negative, I'm going to switch these around a little bit, to the negative 0.5 K. All right, next step, I'm going to isolate that E value by dividing by 15.7. I'm going to leave it like that. So I have 12.8 divided by 15.7 equals E to the negative 0.5 K. This is where we bring in our natural log, right? Whenever I have E to a power, I can eliminate that E by taking the natural log of both sides, right? So I'm going to say ln of 12.8 divided by 15.7 equals ln of E to the negative 0.5 K. That cancels our natural log of E there. So I have ln of 12.7 or 12.5 divided by 15.7 equals negative 0.5 K, and we'll divide by that negative 0.5 to find K. So let's see. Natural log 12.5 divided by 15.7. Close your parentheses, divided by negative 0.5. And our cooling constant, or decay constant, is 0.456. 0.456. We'll use that number. But that's not my question, is it? The question is, when did the guy die? Well, this 0.456 doesn't help us at all. So what we need to do is take this value. It's kind of like when you're given X, I don't know. Thank you, Maddie. It shouldn't have. Y'all keep me in check. This should be 12.8. It's just because let's see. Let's see how it changes. Oh, 4.0. Thank you, Maddie. 0.408. How's that? All right. Thank you for watching that closely. Otherwise, all the numbers will change at some point. Okay, so here we go. Let's rewrite this in a function. You guys remember way back in Algebra 1 where you had to find your slope, and then you had to plug your slope back in and the point to find your equation of line. This is the same thing, okay? It's not anything different. It's just you're using a different kind of formula. All right, so let's see what this says. This is T of T equals 70, right? plus that initial temperature of 85.7 minus 70 E, and now our cooling temperature, or our cooling rate, sorry, like that. So this is our equation that we can find out at any point in time what the temperature of the body is going to be. So we could even plug this in and find out when the temperature of the body is going to be at room temperature, right? So you can use this to work backwards to find out when the man actually died. Or the person. It wasn't, we don't know if it was a man or a woman, do we? So tell me, because I need to know, first of all, what temperature a person is before they die. It's kind of morbid, but tell me in the chat, what is a typical body temperature? Yeah, 98.6, right. So I want to know, when was this man's body, or this man or woman's body temperature at 98.6? Let's find out. This will be very interesting. So we're going to plug that in. 98.6 equals 70 plus 85.7 minus 70, 0.408 T. All right, so we're going to go about it the same way that we did up here, right? Taking the natural log of both sides and finding time. Here's the, oh, it's supposed to be negative, right? Because it's negative K. Here's the kicker. If he was 85.7 degrees at 9 o'clock, what do you think my T value is going to be? Just take a wild guess. Go ahead and put it in the chat. What is your guess? What do you think the T value is going to be? It's not gonna, I'm not gonna get an answer of 7:15, right? I'm gonna get, what am I gonna get? It is time. So some of you are putting in numbers like 5. If I got a T value of 5, that means that my time would be 5 hours from 9 o'clock or since 9 o'clock. So that would mean it would be 10, 11, 12, 1, 2 o'clock, right? So what kind of T value am I going to get? Yes. I love the exclamation point. Yes, you are going to get a negative number because you're counting backwards from 9 o'clock, right? Or I should do it this way because you're looking at it that way. We're going to be counting backwards from 9 o'clock. So you're looking for a negative number. If you don't get a negative number, then you probably need to do something different. All right, so let's go back to our math. We're going to simplify all of this here. So we have 98.6 minus 70, which is 28.6 here, equals 85.7 minus 70, 15.7 E, negative 0.408 T, divide by 15.7. So I have the natural log, I'm moving a little bit quickly here. 15.7 equals the natural log of E to the negative 0.408 T. Those cancel. I have natural log of 28.6 divided by 15.7 equals negative 0.408 T divided by negative 0.408. And let's see what our T is. All right, so we have a negative 1.47 as our T value. So Yes, Jake, we're gonna go over it in just a second, I promise. All right, so that means that this person died an hour, 1.47 hours before 9 o'clock. So can you tell me what that is in hours and minutes? Tell me to the nearest minute what time this person passed. Try again, Joshua. You're really, really close. You guys are almost right on the money. Eduardo, Jamie, Lorelai, Maddie, Megan, what do you guys think? You guys are so close. All right, let's think about this because it's minus, right? Minus 1 hour. So if my initial time was 9 o'clock, right? So I'm starting at 9 o'clock. I'm subtracting 1 hour, right? That gets me at 8 o'clock. Then I'm subtracting this 0.47. So I want to know how much of an hour is 0.47. It's 28.2 minutes, but it's not 28.2 minutes after 7 o'clock or after 8 o'clock. It's 28.2 minutes before 8 o'clock. So what is that number, 28.2 minutes before 8 o'clock? Yeah. So our approximate time of passing, is 7:32. Whew, take a big breath there. If your head is hurting, that's okay. Give yourself a pat on the back because that was quite a whirlwind. I like this. Poor fella died at 7:32. Yes, that's true. Poor guy. So our test is going to be there's one question that's exactly this, okay? So I don't want you to get confused. It is what we've been talking about. So don't think you can't do it. You can do it. And let's look at it right now because I know we're running out of time and you guys have to go to practice and stuff. There has been a murder, a shipwreck and a murder. You and several travelers have been shipwrecked on a tropical island. It's a beautiful place, except there was one of the travelers, John Doe, has been murdered while you guys were shipwrecked there. There's no one else on the island but you and these other travelers. FYI, you are not a suspect, so don't put yourself as a suspect.